Hello and welcome to the channel Let's Learn Electronics. In our last video we solved our first numerical problem on this topic of zener diode. If you have not watched the previous videos and if you are confused with the theory part, please go back to the channel, watch all the videos to have a clear understanding. Anyways, let's proceed ahead. This problem states, for this given zener diode network, determine the range of load resistor, that means RL, and the load current IL, such that the voltage drop VL is maintained 10 volts throughout the operation. So for this, we had studied a formula. I will paste the screenshot of the last video below. I'll show it. Give me a second. Using that formula, we can directly calculate these values. Look at the values first. We are given Vi is equal to 50 volts. The limiting resistor is 1 kilo ohm. The breakdown value is 10 volts and the maximum permissible current which can flow through this zener diode is 32 milli. Oops, let me change it. It's actually milliampere. Here it is 32 milliampere. So let's solve it. This is the screenshot from my last video. I have explained these formulas. If you are confused, then please go back and watch the theory part first. Anyways, we have to determine the minimum value of load resistor which can turn on the zener diode. We have a fixed supply voltage Vi. We have a fixed limiter resistor 1 kilo ohm Rs, or simply R, which is given in the formula. We have to determine this RL minimum, the minimum amount of load current which is required to actually turn on the device zener diode. And obviously when the resistor will have the minimum value, then naturally the current flowing through it would be maximum. We'll get the value of IL maximum from this RL minimum value. So let's calculate that. Simply put all the values in the formula. To calculate RL minimum, we already have the value of limiting resistor R, which is given 1K. Directly put the values in the formula given above. You can also solve the problem side by side on your notebook or scribble on a paper so that you can actually understand it. We have to subtract 50, the Vi, minus the given VL. VL is maintained 10 volts fixed. Solve it and you will get the answer as check your answers. It should be 250 ohm. It's a very simple question. You should be knowing the formula only and then you can easily calculate by simply putting the values. Now if we have the minimum resistor value, then naturally the current flowing through it would be maximum. So let's calculate IL max. The value of IL maximum, let's IL max would be, simply apply Ohm's law. We know that according to Ohm's law, VL upon RL will give us IL maximum 10 upon 250 . The answer comes as 40 milliampere. IL maximum is 40 milliampere. Now this is one part of the question. We have calculated minimum resistance and maximum current. Now we have to calculate the maximum resistance, RL max, and the minimum current. And for that we have our formula. Using this formula we can calculate RL maximum directly. Look at this circuit once again. The current IR is being divided into two branches, IZ and IL. We know that the maximum current which can flow through this branch is IZM. This is 32 milliampere, the maximum permissible current. And obviously when this branch will have the maximum current, then this branch will have the minimum current, which would be IL minimum. This way, from the equation IS is equal to IZ plus IL, we can obtain the values of IL minimum, and we know IZ max. So we can calculate IL minimum using this equation. Once we will know the IL minimum value, we can calculate the RL max value using that formula. Let's proceed to calculate this IR, and for this IR we need VR. We can simply calculate this VR by putting the values VI minus this VZ. VI minus VZ will give us the potential difference value VR. We can calculate it orally. VI 50 minus VZ. 10. 50 minus 10 is 40. Let's write it somewhere and understand it properly. Here we have written it. We can directly get the value 40 upon 1K. It gives us 40 milliampere. 40 upon 1 kilo ohm. This is 40 milliampere, the value of limiting resistor. This is 40 milliampere. The IZ maximum is 32 milliampere. It is given, it is mentioned in the circuit diagram. Then we can calculate the value of IL minimum orally once again. Before I write, calculate IL minimum. 40 minus 32, it is 8 milliampere. I don't have to waste my time in writing. Let me just pause it, and this is the value for IL minimum. When we have this value, when we know that VL is fixed 10 volts throughout the operation, then using Ohm's law we can calculate RL maximum. This is 10 upon 8 milliampere. Here we have 10 upon 8 into 10 raised to the power minus 3. Calculate this fraction and you will get 1.25 kilo ohm. This is the solution of this problem. Let me summarize it. This is the range of load resistor which this voltage regulator circuit can work with, which this load resistor can handle. The minimum range is 250 ohm and the maximum value is 1.25 kilo ohm. And this is how we can get the current values using this resistors. So we are done with our second numerical. We will be coming up with more numerical problems and new topics on this basic electronics syllabus. Wait for the upcoming videos. Click on the bell icon to stay connected with us and get the regular updates. Subscribe the channel, watch and like all the videos. Study hard, stay connected, keep watching and learning with Let's Learn Electronics. Thank you for watching the video. Bye bye.